Hello, everyone, and welcome to Solving and Compound Inequalities. Compound inequalities includes two inequalities that we will graph on one number line and write one solution for. The solution to the and type inequalities are the solutions that both of the inequalities have in common. Another way to look at that is the intersection of the two solutions. So if you had a Venn diagram, then this area here would be the and, what they both have in common. Okay, so let's look at a few examples of solving compound inequalities, the and type. All right, so first of all, you would just solve the inequalities separately. So here I would subtract 1. That gives me x is greater than or equal to 6. On this one, I would add 1. And then divide by 3. That gives me x is greater than or equal to 2. Now I'm going to graph those separately. So let's look at the x is greater than or equal to 6 first. Now remember, we're graphing using the interval notation style. So I would use a bracket since I have the or equal to bar, starting at 6 and going to positive infinity. With x is greater than or equal to 2, I would have a bracket at 2, going to positive infinity. Now, the solution to this is where they are both shaded at the same time. So if you look here, this is the area where they are both shaded. That's my solution. So my solution graph would be from 6 on to positive infinity, because that's where they're both shaded at the same time. For interval notation, we would have bracket 6, comma, positive infinity, and remember, you always have a parentheses with the infinity symbol. So that's one way to help get you started with these. You can graph both of the graphs and inequalities individually, see where they overlap each other, and that is your solution for the compound inequality. Okay, let's look at another one. All right, this one we have 7x minus 1 is less than or equal to 6, and 7x minus 1 is greater than or equal to negative 15. So you don't see the word and, but if you have that variable in the middle with the two inequalities, it's understood to be an and inequality. And you would solve this just like you would solve any other inequality. However, whatever you do in the middle to get x by itself, you have to do on each side. So I have 7x minus 1, so the first thing that I would do would be to add 1. If I add 1 in the middle, I have to add 1 to each side on each end. So now I have 7x is less than or equal to 7, and 7x is greater than or equal to negative 14. So now we would divide by 7. So what this says, if I wrote it separately, is that x is greater than or equal to negative 2, and x is less than or equal to 1. Reading from the x is greater than or equal to negative 2, and x is less than or equal to 1. So let's graph the x is greater than or equal to negative 2. So again, I have the or equal to bar, so I have a bracket. Greater than would be to the right. X is less than or equal to 1. So again, I have the bracket at positive 1. Shading to the left. So where the two graphs overlap, that is my final solution. So you can see that the two graphs are both shaded from negative 2 to positive 1. And we have brackets on each end. So that would be my solution. Bracket negative 2, comma, 1, bracket would be my solution. Okay, let's take a look at one more. All right, so here we have another and inequality. We have x minus 1 over 10 is less than 7, and x minus 1 over 10 is greater than 2/5. So just like we did before to clear the fractions, we want to clear the fractions here. So my common denominator for 5 and 10 is 10. So I'm going to multiply each side and the middle by 10. So 10 times 2/5. Remember, that's the same thing as 10 over 1. So 5 goes into 10 2 times. That gives me 2 times the 2 that's already up there. Have to use my distributive property here because of that minus there. 10 times x is 10x. 10 times 1/10. 10 will go into 10 one time. And I already have a 1 up there, so 1 times 1. And 7 times 10 is 70. Okay, so let's clean up that multiplication. 4, 1. Now we want to isolate x. So we're trying to get x by itself. And remember, whatever I do in the middle, I do to each end. So now I have 10x is greater than 5, and 10x is less than 71. So the final step to make this 1x would be to divide by 10. So 5 over 10 is 1/2. 10 over 10 cancels. That's 1x. 71 over 10 is just 71 over 10. So I have x is greater than 1/2 and x is less than 71 over 10. So if x is greater than 1/2, 1/2 is about right here. Now notice we do not have the or equal to, so it would be a parentheses. X is less than 71 over 10. That's the same thing as 7 1/10. So just a little bit beyond 7 here, parentheses to the left. And as you can see, they overlap in between those two numbers. It's like saying I have more than 1/2, but less than 71/10. They overlap right here in between the two numbers. So my final answer, parentheses, 1/2, comma, going to 71/10, and parentheses there. And again, I use parentheses this time because I did not have the or equal to bar. All righty. I hope you found that to be helpful. Thank you.